All right, this is the Check Your Understanding on page 607. Bernadette also plays video games and worries about connecting with her friends. They give us the breakdown of the table right here. Find the probability that Bernadette plays video games and connects with her friends. So I'm going to write that in probability notation. We want the probability that Bernadette plays video games and then she connects with her friends. So here's the plays video games, here's connects with her friends. We learned from the example earlier that all we had to do was multiply, and that gives us 0.08. To find the probability that she connects with her friends, she has to either, remember, here's connects with her friends, so there's two different paths. She can connect with her friends after she's played video games, or she connect with her friends after she has not played video games. So there's going to be two sets of numbers. We're going to take these two and multiply them together, and then we're going to take these two and multiply them together, and then we're going to add those outcomes. So we're going to do 0.2 times 0.4, and we're going to add that to 0.8 times 0.7, and when we get that all multiplied out, we end up with 0.64. Why is it possible to add in order to find the probability in number 11? Because these two outcomes are mutually exclusive. Remember, you can't have any part where you're playing videos and not playing videos at the same time. So they're mutually exclusive. So since they're mutually exclusive, all you have to do is add. The mutually exclusive events is what allows you to add. Mutually exclusive event. All right, and it says write the probability that Bernadette connects with her friends given that she does not play video games. So they want the probability that she connects with her friends, but what has already happened given she did not play video games. Remember, each one of these is a conditional probability. So all we've got to do is find that she connects with her friends given that she has not played video games. So the answer is 0.7. Okay. All right. Now we're going to go on to number 14. And number 14, they talk about Miss Troy's math class. So in the math class, there are 18 girls and there are 12 boys. So what's the total number of students that is in Miss Troy's class? If she has 18 females and 12 males, 18 girls, 12 boys, that's a total of 30 students. Okay? So, and the reason that I wanted to know that, because in order to find the probability, we need a desired event on top with the total sample space on bottom. Total sample space. So the event that we want is girl. So we want to find out what the probability of picking a girl. And the total sample space would be the total number of students. So how many girls are there to pick from? 18 out of a total of 30 students. So the probability of picking a girl is 18 out of 30. And did it say anywhere? It talks about right here without replacement. So we need to be sure and talk about that. These are dependent events because it's without replacement. We'll talk about that as we go along here. She randomly picked one slip from the hat, and then without replacing the first slip, see, she didn't put anything back. She will randomly pick a second slip. What's the probability that the first student selected is a girl? There was 18 slips of paper in the hat out of 30 total pieces of paper. So that's why it is 18 over 30. And I don't see anywhere where it said write it as a decimal, but I think I went ahead and did it anyway. So I think that comes out to be 0.6. Okay, so now it says, if the first student selected is a girl, how many slips of paper for girls are now left in the hat? Okay, so we've picked one slip of paper out, and it was a girl. Are there still 18 slips of paper? No, there's not. There's only 17 slips of paper. And how many total pieces of paper are left in the hat? I picked one out. Whether it's a girl or not, I no longer have 30 slips of paper in the hat. I now have 29. So the probability, it says, what is the probability that the second student will also be a girl? So this 17 over 29 happened because I picked a girl's name out and I changed the number of things that were in the hat because I did not put it back. So this is the probability of the first and the second being a girl. Now it says, if the first student selected is a boy, how many slips of paper for girls are left in the hat? Now remember, the first, now they're telling us that the first piece of paper that they pulled out had a boy's name on it, was a boy. So that means that I still have 18 pieces of paper in the hat that are girls' names. I didn't pick a girl's name the first time, I picked a boy. But how many pieces of paper are there now in the hat? There's still 29 in there because I pulled the boy's name out and I did not put it back. So if you understand this process right here, then this process that we're going through right here will help us put the probabilities of these outcomes happening. So it told us, we calculated up above when we did this one right here, that 18 out of 30 came out to be 0.6. Now, I really think it's helpful to do 18 out of 30. Springboard does not do this. They go ahead and just put down 0.6. But I think it's helpful to see because you have to understand that we have without replacement. This is important because the second student, we no longer have 30 names in the hat. We only have 29. And if I had 18 girls' names, I picked a girl's name. Now I only have 17 girls' names. So 17 over 29 is the chance or the probability that goes here. Now that came out to be a decimal. So Springboard didn't put it as a decimal because we're going to be doing some calculations with these. And so you don't want to round off and then do more calculations. So we're just going to leave it 17 over 29. That's why I kind of like leaving this 18 over 30. But anyway. Okay, so for the boys, if there are 12 out of 30, 12 boys out of a total of 30 students, that comes out to be 0.4. Okay, that point's really in the wrong place, but I can't erase it, so I'll just leave it right there. That comes out to be 0.4. Now, if we pull a boy's name out of the hat, I no longer have 30 students, I only have 29, but I had 18 girls to begin with. I pulled out a boy, so I still have 18 girls. And then down here, I originally had 12 boy names, but I pulled a boy's name out, so now I only have 11 boys' names. And 11 out of 29. And yes, I know that looks like an H. So this is what they wanted us to do, write the relevant probabilities on the tree diagram. So you need to kind of keep in mind of how you build this, because you're going to have to build one in just a minute on a check your understanding. So I'm going to go on now to part E, and part E says, find the probability that both students chosen are girls. So what they want us to find is the probability of a girl, drawing a girl's name, and then drawing another girl's name, the probability of a girl and a girl. And just like we did a while ago, we got probability of drawing a girl, 0.6. And then the second girl, 17 over 29, we just got those and we multiplied them together. So this came out to be 0.6 times 17 over 29. That's how it worked the first time we did a table. And that comes out to be about 0.352. I don't know where they told us to round to 3 decimal places, but that's what the answer key did. And it says, hey, are you paying attention to what's happening here? Have you paid attention that anytime we find the probability of an and, then we end up multiplying those two numbers together? And if you understand what the probability of this is, remember, this is the probability of picking a girl. This was the probability of picking a girl. And this was the probability of picking a girl given that you'd already picked a girl. This is the probability of picking a boy, but given that we've already picked a girl. And by the way, if we picked a girl the first time, then we still have 12 boys' names in the hat, but we've already drawn one name out. It was a girl's name, so the probability of picking a boy is 12 out of 29. So this outcome right here, this 12 over 29, is the probability of a boy given a girl. So when we multiply those two things together, we're using this formula right here that says if you find, if you're looking for finding the probability of an and problem, and you're working with dependent events, then this is what you have to do. You don't multiply the probability of A times the probability of B. You multiply the probability of A times the probability of B, given that A has already happened. And that's why these charts are so handy. If they are independent, this is from another lesson. If A and B are independent, you just, to find the probability of A and B, you just multiply the probability of A times the probability of B. And they would be independent if you replaced the name. So if you put the name in the hat and you pulled it out and then you put it back and then you drew a second one, those would be independent events, because what you drew on the second one what you drew on the first one did not change what you drew on the second one. So those would be independent events, and then all you do is find the probability of A times the probability of B. But with this one, because what you do that first time right here changes the outcome of the other, then these are dependent events, and this is what you have to do. You have to multiply probability of A times probability of B given A. So it says, okay, find the probability that a girl and a boy are chosen. Now you have to be careful here because they are being really, really tricky, and they didn't tell you, does it matter, does the girl have to come first or does the boy have to come first? It doesn't matter. So since it doesn't matter, you've got to, the probability of drawing a girl and a boy, you have to consider the probability of the girl being first or the probability of the boy being first. there's two different outcomes. And I really shouldn't use this same notation. This just says, find the probability that you get a boy and a girl. This is giving me order. The girl and then the boy. A boy and then the girl. This right here, they're not giving me an order. I just want a probability of a boy and a girl. So I have to put these two together. So this is going to be, and I'm using the chart, 0.6. Oh, I think I wrote it backwards. Hold on. Probability of a girl. Yeah, probability of a girl is 6, and then a boy is 12 over 29. So 0.6 times 12 over 29 plus probability of a boy, that's 0.4, times, what is that? Boy and then a girl, 18 over 29. That would be 18 over 29. And to write this out using this formula, this 0.6 is the probability of the girl happening. And then we're multiplying that times the probability of a boy, given that a girl was already chosen. So remember, each one of these numbers out here, there's the probability of a boy given that a girl was already chosen. So the probability of a girl times the probability of a boy given a girl was already chosen. So that's what we're multiplying together right there, which is exactly what that formula says. So we're doing a girl and then a boy. So we multiplied this. Now we're doing a probability of a boy. That's this one right here. And this is the probability of a girl given that the boy has already been chosen. So this formula is being applied twice. And when you do all of that multiplication and then you combine, you get about 0.497. Okay, so I'm going to stop the video here, and you're going to do the check your understanding and go ahead and do the lesson practice. So the next video will be me just going over the answers.